Okay, so this is section 1.2. First question is, they give you a table and they ask you, is this relation a function? Well, first off, a relation is simply any two numbers that are coordinated together. So these are definitely a relation because any number can be compared to another number. It doesn't matter. But a function has a very specific rule. For each x, there must only be one y. Now, 9. How many nines are there? There's only one 9, and that 9 is related to 5. That's only one y, isn't it? 8. There's only one 8 here. It's related to 16. That's fine. There's only a 1 3 here. It's related to 5. There's only a 2 here, and it's related to minus 4. Good. And 1 here, it's related to minus 4. Well, the fact that they're both related to the same number does not matter. It just says for each x, there's only one y. That's a function. Alright, now the domain is simply all of the x values. The range is all of the y values. Notice I don't write the y values down twice. Okay, and number 5, they ask you to use the vertical line test to see if these are functions or not. This one passes the vertical line test. This one does not. Notice if you draw a vertical line here, maybe at x equals 1, you've got a positive y and a negative y. So 1x is relating to two different y's. That's why it fails the vertical line test. Number 6, same idea, fails. B, passes. 8, if you graph it, it's a parabola. It's going to pass the vertical line test. B, this one's a little trickier, but it's basically a half circle if you draw it. But another way is you can say, let's plug in one value for x and see if we can get two different values for y. Well, 10 times 1 squared is 10. What number times itself equals 10? Well, negative square root of 10. And same thing here, 10 equals square root of 10 squared. So yeah, that works. Now number 9, they're asking you to take the function and do what I do, which is write f of blank, right? And so you got r of blank equals 8 times blank minus 10. So r of 0 equals 8 times 0 minus 10. r of 2 equals 8 times 2 minus 10. r of negative 3 equals 8 times negative 3 minus 10, and so on. Okay? Same thing here. 4 times blank squared minus 3. 4 times 0 squared minus 3. 4 times negative 1 minus 3, and so on. The only ones that are tricky are maybe where they're negative or where they're fractions or decimals. You got to watch your math there. 15, you've got blank cubed minus 4 over blank. Well, here's your guy, so it's blank cubed minus 4 over blank. And you got to watch your double fractions there and your negatives. 2 cubed minus 4 over 2. Negative 2 cubed minus 4 over negative 2. Alright, so those are all pretty straightforward as long as you watch your algebra there. Same thing here. Alright, now this one is asking you 5 different questions. A, C, and D are asking you about common errors that students sometimes make. So first they ask you, does f of 2 plus 1 equal f of 2 plus f of 1? In other words, can you distribute the f like you would in multiplication? Well, we're going to find out you can't. Alright, so let's look at f of 2 plus 1, that's f of 3. And when you plug in a 3 there, it's 1 plus blank squared. 1 plus blank squared, where blank is a 3. Try f of 2, 1 plus blank squared, or 1 plus 2 squared. 1, let's plug in a 1, 1 plus blank squared is 1 plus 1 squared. So now, here's the original question. We ask yourself, are they equal? Well, we know the left side equals 13. We know the right side equals 7 plus 3. And we know 13 does not equal 10. So this is another, let's look at C. C is another question that's a very common error for students. Alright, so C says, does f of x plus h equal f of x plus f of h? Very similar to A. They're asking you, does f of x and f of h adding together equal the same thing? It doesn't, and I'll show you why. Because we get f of x plus h, which is this. We get that from part B. I'll show you that in a minute. then on the right side, f of x is the original function right there. And this is the function with a h in it. So now does the left equal the right? No, because 2xh does not equal any, there's no 2xh on that side. And now d is slightly different. D says, does f of x plus h equal f of x plus just h? Well, we know f of x plus h. We got that from part B, and I'm going to show you that in a minute. F of x is 1 plus x squared. We know that. And h is your last term there. All right. Does that side equal that side? No. This one has a 2xh and that one doesn't. Alright, so now here's the basic question that we're going to be doing over and over and over again. We're going to try and answer this fraction right here. This fraction right here asks us f of x plus h minus f of x all over h. And so to know this, we already know what f of x is, we already know what h is, they give us those, but we don't know this guy when we start the question. So that's why we do this part here. We take, remember it's 1 plus blank squared. Well, what's in the blank? X plus h. You can drop your brackets there, parentheses there, and this one you got to square it, so be careful. X plus h times itself gives you this guy. Okay, so now here, what we just figured out goes in the first bracket. Then subtract, and what goes here is the original function. And it's all over h. Okay, so now when you drop all these brackets, you get 1 plus x plus h x squared plus 2xh plus h squared. Nothing changed there. And now you hit each one of these with that negative sign or subtraction sign, so you get subtract 1, subtract x squared over h. Now what cancels? 1, 2, 3, 4, 5, 6 terms cancel. A 1 and a minus 1. A minus x and a plus x. An x squared and a minus x squared. Now at this point, you can check yourself to see if you're doing it right, because you should have all terms that have an h in them. Every single term has an h. Now you can cancel an h with each one in its own way, or if you want to, you can factor an h out of this top term and cancel it with the bottom. I don't care which way you do it. Alright, 19 and 20 are the same thing. Yeah, 19 and 20 are exactly the same question. Okay, so I said you got rectangle minus triangle over h. Rectangle, you got to figure that out, and we will. Triangle, they give it to us. That's the original function. And then we know what h is. It's just another letter. Alright, so f of blank equals blank minus 2 times blank squared. F of blank equals blank minus 2 times blank squared, where x plus h goes in the blank. Drop the parentheses there, and I multiplied this times itself, got that, and then I multiplied each one by a negative 2. I was careful, I tried to do it in 2 steps instead of 1. So now, this guy is your rectangle. It goes right there in the first bracket. And then the triangle goes there in the second bracket. That's the original function itself. Now when you drop your parentheses or your brackets, nothing changes in the first, but in the second you hit each one with a negative sign. Okay, so you've got x plus h, you get this whole thing, and x and a minus x cancel, minus 2x squared and positive 2x squared cancel, and you're left only with terms that have an h. Alright, so then I factor out an h, okay, and I can cancel it and I get this guy, or you can go straight to that, either way. 20, same idea. 2 times blank squared minus blank plus 3. 2 times blank squared minus blank plus 3. So f of x plus h is 2 times blank squared minus blank plus 3. X plus h goes in the blanks. You multiply it out, and you multiply each one by 2. You distribute that negative sign to each one of those, and you got this big long thing here. So that's your rectangle. It goes in the first spot. The second spot is your original function itself. That's what they give us. Now when you drop this without the brackets, you're going to hit each one of these three with a negative sign, changing its sign. You're going to cancel like terms. Only terms that have an h are left. And again, you can factor out the h out of the top and then cancel. Or you can just cancel an h with each term. Either way is fine with me. All right, now 21. 21 gives you, it says there's a graph in problem 5a, and they ask you to find f of 9. So you find where x equals 9 and look at the y coordinate, it's 10. F of 5, you look where x equals 5 and find the y coordinate, it's 6. 27, they say state the domain and range of the function. So for domain, all you're worrying about is square roots and fractions. Here you got a square root and you force what's underneath greater than or equal to 0. And when you add or subtract 4, you get x is greater than or equal to negative 4. You have to graph it pretty much to figure out the range, but the range is 0 values or higher for the y's. The x values are minus 4 or larger for the x's. So I could have just as easily said domain is minus 4 to infinity. Same thing. 32. Okay, this one's a little tricky, but they give you a graph of it. When you look at the graph, you can see that it's kind of like this. Okay, and when you smush it onto the x-axis like a pancake, it touches at minus 3 and positive 3. If you squish this thing this way, on the y-axis, it goes from minus 2 to 5, minus 5 to minus 2. You'll see it when you look at the picture in the book. Alright, now this one, 33 and 35, are both the same way. They're really not that hard of a question, it's just that the book makes it hard by writing these questions like this. This just means f plus g. This just means f subtract g. This means f times g. And this means f divided by g. That's all it means. So if f is 3x and g is x cubed, it's just 3x plus x cubed. 3x minus x cubed. 3x times x cubed. And 3x divided by x cubed. Now each one sometimes can simplify here. If you can do that, do it. Same thing here. Square root of 2x and x squared. So addition, each of them are added. Subtraction, each of them are subtracted. Multiply, each of them are multiplied. Divide, each of them are divided. Okay? And so then you got 37. 37 is you're given this guy and you're given this guy, and they ask you to find f circle g, g circle f circle f, and f squared. This last one is not really a composite function. It's f times f. Alright, a composite function is simply a function within a function. Alright, so you're going to say f circle g of x is f of g of x. So the second guy goes on the inside, first guy goes on the outside. G circle f is g of f of x. F circle f is f of x. Okay? Now how do you go from here? Well, you build from the inside out. You know what g is. You know what g is. It's 1 minus 2x. So you put 1 minus 2x in there. And you know what f is. It says whatever you got minus 1 and cube it. Whatever you got, subtract 1 and cube it. You can simplify that and you get negative 8x cubed. G circle f is g of f of x. Well, we know what f is. F is x minus 1 cubed. So we put x minus 1 cubed in there. And now what do we do next? Well, whatever g says. G says 1 minus 2 times blank. 1 minus 2 times blank, and our blank was x minus 1 cubed. F circle f is f of x. Well, that's x minus 1 cubed. And now we put that guy in there, subtract 1 and cube it. That guy in there, subtract 1 and cube it. Okay? Then finally this one is just f times f, right? This is just f times f, which is x minus 1 cubed times x minus 1 cubed. Okay? So composite functions are tricky. Typically they ask you these 4 questions. Notice they didn't ask us this last one. They asked us just the first 3 for some strange reason.